actual on the
Thank you,
objects
Anton. No,
as
I'm
they
blue.
pass through these
Appreciate
tails
that.
once in a
You
while.
know, person.
But I guess the first question is, well, how are these tails even formed? Well, as this NASA video shows, it's
I
really
wish,
through the
kind of,
interaction
honestly,
with
you would
the
just be like,
sun
you
and
feel good about
specifically
yourself,
the
person. I had to
very
do the
highly
more long
charged
video
particles
about.
coming from the
You feel
sun.
good about that?
They sort of wrap around the planet or around the moon and end up creating this beautiful charged tail that's visible around many different objects, including in this case Venus. Or, as you might have heard from the slightly younger Anton
dual
right
spring,
here,
spool
from the
pin,
video above, it
pin,
also
or
seems to appear
pin,
around Mercury
5 or
and
6,
is
6
easily
pin, 6
visible,
pin.
assuming you have the right filter.
Okay.
Alright, this sort of looks weird. There's like two of me, and both of me are talking about similar but different things. Let's go back to the idea of tails. So all objects seem to produce them because the sun kind of makes them because of the interaction of different charged particles. Their content, though, depends on what's being emitted. So, for example, for Venus, it's mostly stuff from the atmosphere. For Earth, it's also mostly stuff from the atmosphere. And
well, I like this graph you did earlier. I would
moon,
take that piece out of there. Well, there's the internet out there,
here.
but I'd give him as much as I possibly could.
Little
But, like, well, I got a
from the
business to keep. I kept keeping nickel, brother, but the moon, tide,
and
waves.
essentially what you would refer to as the exosphere. There's this famous image from NASA
It's
from
like
the
this
Apollo
thing.
missions
I know I'm not going to
that
get this.
shows
I
us
can't beat him
the
for that. So he
lunar
always points
horizon
kid
glow.
over there. Go
And
get
this
some
really
notes.
sort of illuminates this
Classroom.
tiny,
Put
tiny
on
exosphere,
Patreon.
or this really thin
If you like what he
atmosphere
does.
that exists around the moon and also exists around most
Plus
other
me.
objects in the
Okay.
solar system. Now, in this case, the actual content of it is
I'm not breaking my
presently
picks on
unknown,
this.
but different molecules have already been detected over the past few decades. There seems to be a little bit of oxygen, a little bit of helium,
Try to go down
a
to
little
the
bit of
front door or
argon,
something.
also things like methane, nitrogen, carbon monoxide,
nitrogen,
and carbon dioxide,
Carbon dioxide.
but also large amounts of sodium and potassium. And it's really the sodium that we're kind of interested in. Just like in the video about Mercury, it's very likely the sodium tail that seems to reach all the way to Earth and produces the most observable effects we're seeing from planet Earth. Although it's very possible that a lot of other elements are also present here as well. But where is all of the sodium coming from? Well, actually, from the same location or from the same source
tool in
as
itself
we
is
find
still good.
in the region in the upper atmosphere of our planet known as the sodium layer. And sodium layer is easily visible in this picture from NASA because it forms this obvious yellow orangey line that wraps all
magnetic
around the planet.
waves.
And all of this is made of
Internal
various
housing.
matter coming from outer space, specifically
Fusion.
meteorites and
I said I was blue
micrometeorites
earlier.
that burn up in the upper atmosphere and leave behind a lot of sodium that then starts to produce a lot of this orangey glow because of the
Makes that
illumination
this.
from the sun. But all of these micrometeorites and asteroids also end up on the moon.
By
And
math.
since there's no atmosphere, they end up colliding, producing a lot of different tiny collisions on the surface, dislodging a lot of different particles from the surface.
That's the joke
which then
about fair
eventually
usage.
results in this. And because there's a lot of electrostatic on the surface of the moon and a lot of different electromagnetic effects that sort of make this float and circulate above the surface of the moon, it all ends up sort of hanging there until the solar radiation comes in, bombards the
Evolution
surface
of
of the moon,
crab.
and
Nope.
dislodges all of these electrostatically charged particles. And so once all of this stuff starts to leave the moon, it creates the tail behind it. And the tail itself is really large. And obviously, once in a while, Earth passes through it. But it seems that for the most part,
Ones and
all these
zeros,
particles
never
from this tail end up sort of circulating around the planet, with some also ending up in the sodium layer of planet Earth. But the vast majority of the particles simply leave the planet on the other side, escaping into the interplanetary space. Which also means that all of these particles coming from the moon are definitely harmless and generally have almost no effect on our planet at all. However, every month for a few days, the glow does become visible to some really highly powered telescopes that usually start reporting very faint orange glow in the skies, which also seems to occasionally increase in power. Although for the most part, it sort of looks like this. This is almost exactly what the scientists usually see. It's this really
They're looking
fuzzy
through a
spot,
telescope right now.
usually on the other side from the sun, and is normally about 5 times larger than the moon is in the
Turn on
night
the
skies,
switch.
but about 50 times dimmer than the light that the human eye can perceive. So you do need to have a special telescope to be able to detect this. And because its brightness
We
seems
have
to
this
fluctuate from time
and
to time,
stars. We're looking
the
through
scientists
this.
really
Well,
wanted
you're
to find
sitting
out
over
what's
here.
really
One of
going
you.
on here. How come the brightness changes? Is it because of the solar cycles?
Well, if he's over here, that means
Is it because
things
of
right.
the differences in
Move
orbit
from this
as the
way.
moon orbits around
So I
the
move
Earth?
this way.
Or does it
I
have
lean
something to
into
do
this
with
one.
the Earth's atmosphere? And so the scientists whose paper you can find in the description analyzed approximately 21,000 photos from about 13 years of different observations in order to discover any possible patterns and any possible explanations to why this particular sodium tail varied from time to time. So for example, one of the obvious discoveries was that the spot was a little bit brighter when the moon was a little bit closer to planet Earth. That kind of makes sense. You know, it's coming from the moon, so obviously the closer the moon is, the more effects we'll see. It also seems to peak and be the brightest when the moon is what's known as the new moon. And so about 5 hours after the new moon, that's when the sodium tail seems to be at the brightest possible. And that's of course because of the orbital locations here, with the sun being almost exactly behind the moon and blasting it with a lot of energy that's creating all these particles headed toward planet Earth. But surprisingly, there was absolutely no correlation with the solar activity, including the solar cycle. No matter how active or inactive the sun was, the power of the tail and the brightness of the tail didn't change almost at all. And so the tail seems to be a natural formation independent of how much energy the sun is emitting toward us. There was also no correlation with any other solar effects, such as, for example, electron pressure, helium pressure, density or speed of plasma in the interplanetary space. And so, for the most part, the effect was always there and was always more or less permanent. But it did have one interesting pattern that was somewhat related to what was happening on the surface of the moon. It seems that there is a kind of a pattern every 4 years, a pattern that's related to various collisions happening on the surface of the moon. Okay, so this particular simulation is actually a little bit exaggerated. Here we're talking about micrometeorites, but every 4 years, the moon and planet Earth experience an increase in micrometeorite collisions. This is a more or less sporadic event that happens as both Earth and Moon orbit around the solar system, and it's not really related to any specific meteor shower or asteroid shower or any other specific event, but these random encounters and these sporadic events do seem to contribute the most to the overall brightness of this sodium tail, with the most reasonable explanation being that, well, unlike a typical meteor shower, an occasional collision with a slightly larger meteorite
satisfaction
is more
of
likely
general
to
field theory
release a lot more
equation
material into the exosphere, and thus create a much brighter tail as a result. And if a large enough collision occurs and a large enough asteroid ends up colliding with the moon, it might even produce such a tremendously powerful tail that is going to be easily visible with the naked eye looking into the night skies. Now, it's not something that has happened just yet, and it's not something that we expect to happen anytime soon. But based on the idea of the exosphere on the moon and how we believe it's formed, a large enough strike on the moon will definitely be enough to produce observable effects that are going to be easily visible
I'm gonna have to sit down and be dead.
Bright sodium tail emanating through the night skies, approximately 5 times larger than the full moon. And this type of glow might have happened in the past, and might have even surprised certain early astronomers, but they probably had
put that
absolutely
motivation
no idea
to
what we're
bunnies in
looking
the
at.
backyard
But if it
and
happens
just
in
go
the
wild
future,
and make the
we'll
other
know
guy chase
exactly
it.
how to analyze it and what to look for. So in some sense, I secretly hope something does collide with the moon sometime soon. But anyway, on that note, it's definitely a very interesting discovery.
Come on,
It's still not entirely clear if this has any other effect on the planet Earth other than just the visual effects, but chances are we might discover more about this in the next few years. Until then though, thank you for watching, subscribe if you still haven't, share this with someone who loves learning about space and sciences, maybe come back tomorrow to learn something else, and also check out the videos from the wonderful Dr. James Donahue, whose video I've been using as a simulation here and who's been making these incredibly awesome animations related to astronomy for many years now. Also, maybe support the channel Patreon by joining the channel membership or by buying the Wonderful Person t-shirt you can find in the description.
Maybe.
Either way, stay wonderful, I'll see you tomorrow, and as always, bye-bye.
Well played. Yeah, the next one.